Okay. Next is acetoacetic ester synthesis. This is another important method. The ketone form பண்றதுக்கு. The compound is called ethyl acetoacetate. இதில் வந்து you can see ரெண்டு மொத்தம் 4 கார்பன். It is prepared from ethyl acetate with sodium methoxide. Sodium methoxide is a powerful base. That's ETO minus and sodium plus. The ETO minus can abstract a hydrogen from this CH3COAT, form CH2 minus the anion of ethyl acetate. The anion here will react with this carbonyl group and remove the OET group. You get this molecule CH3 CO CH2 CO OET. This I will just write this slightly differently. The CH2 minus comes here and this goes to the oxygen atom. Therefore, you have CH2 COOET and this one will eliminate the OET to form the double bond. Essentially, this is similar to 2 hydroxy group. Instead of 2 hydroxy groups, you have a hydroxy group and an ether group. The ether group is expelled and you get the acetoacetate. The ethyl acetoacetate எடுத்துட்டு அதில் sodium methoxide treat பண்ணாக்க again it will abstract this hydrogen. இந்த hydrogen வந்து very acidic because it is flanked by 2 carbonyl group. இந்த பக்கம் ஒரு carbonyl group, இந்த பக்கம் ஒரு carbonyl group. So in the hydrogen becomes very acidic because this is electronegative, this is electronegative. So this becomes very easy to break and ethoxide will take this hydrogen as proton and you get the anion of the ethyl acetoacetate. The anion வந்து alkyl halide ஓட react பண்ணாக்க you get the R substitute here. This minus attacks the R group, the X is removed and you get this R group attached here. This is alkyl ethyl acetoacetate. The R group is the alkyl group. It cannot be used for aromatic halide because aromatic halides do not easily undergo the removal of chlorine. So this bond in aromatic group on X is very strong and it will not be displaced by this negative charge. So it can be used for only alkylation, not arylation. அதனால இந்த R group வந்து இங்கே அட்டாச் பண்ணிட்டனாக்க therefore suppose you hydrolyze this to form this OET turning to H. And the carboxyl group will very easily undergo decarboxylation. The carbon dioxide release ஆகுது பாருங்க. இந்த இடத்துல வந்து carboxyl group form ஆகும் first the hydrolysisல. And the carboxyl group will get decarboxylated, carbon dioxide will come out and one molecule of ethanol will be also produced. And then if you take that compound with acid, you will get this ketone. You have you started with 2 carbon acetate and you get 1, 2, 3, 4 carbon ketone. So, this is the preparation of ketone using the acetoacetic ester. It is a very important method of producing substituted ketones. Now, we go to the reactions of carbonyl compounds. Nucleophilic addition. Nucleophilic means a center which is having partial positive or full positive charge. The carbon on the is it will attract the electrophile. This itself is a nucleophile. This carbon electron rich, this carbon is electron deficient. So, if you treat a ketone with a negative ion Z minus, this will begin to add here to this carbon, and this group will partially become O minus. So, that is indicated here. Also, this is the linear molecule or planar molecule, R prime, R, C, O, all are in the same plane. Once in the Z minus on the attack panni, you get a partial tetrahedral structure. Carbon tetrahedral irukka mari, the 2R and O, Z are all very close to getting to tetrahedral structure. Konja nera aachunaka, the Z will form a full bond. So, CZ, and this OC will also form a full bond. This will become fully negative. So, this now is fully tetrahedral. This is the water present in the reaction. It will abstract the proton from water. It forms the corresponding alcohol. So, in the reaction of carbonyl compound with Z will produce addition of the carbanion to the carbon and the production of OH group on the carbon. Now, we look at the properties we have seen so far: preparation of aldehyde and preparation of ketone. We looked at various methods of preparing aldehydes by selective oxidation and selective reduction, and the preparation of ketones by oxidation of secondary alcohols and also using lithium dimethyl copper reacting with acid chloride. Now, we will look at some chemical properties of this aldehydes and ketones. First, we will take the aldehydes. The aldehydes ரொம்ப ஈஸியாக ஆசிடாக போயிடும். அது நான் முன்னாடியே சொல்லியிருக்கேன். அதனால தான் ஆல்டிஹைட் ப்ரிப்பரேஷனில் ரொம்ப கேர்ஃபுல்லாக இருக்கணும். யூ சூஸ் தி ரியேஜென்ட். இந்த ரொம்ப மைல்டு ரியேஜென்ட்டாக யூஸ் பண்ணால் தான் ஆல்டிஹைடோடு நிற்கும். இல்லாட்டா aldehyde will get oxidized to acid. Now, there are two reagents that are used in the oxidation. One is AgNH3 plus. This is called the tolerance reagent. இது வந்து you take silver nitrate and add ammonia, you will get silver hydroxide. You add excess ammonia, முதல்ல precipitate ஆகும் silver hydroxide. If you add excess ammonia, solution clear ஆகிடும். அப்போ வந்து இந்த complex of silver will be formed, AgNH3 plus. This is a metal complex. All the metals are capable of reacting with various molecules or atoms to form complexes. Silver forms a complex with ammonia. Because silver is positive, ammonia is neutral, in the complex on the AgNH3 plus. This is called the tolerance reagent. By preparing AgNO3, adding NH3 till silver hydroxide is precipitated, அதுக்கு மேலே excess NH3 ஆட் பண்ணால் it forms the tolerance reagent. The tolerance reagent ஓட aldehyde react பண்ணாக்க corresponding acid is formed. the aldehyde gets oxidized to the acid, silver gets reduced to silver. You get a black precipitate of silver. And the silver reaction it will be in very very small particle size. Adinala shiny silver mari irukadhu, black precipitate varum. Another method, if you take aldehyde and oxidize it with KMnO4 or dichromate, you get the acid. Once the acid is there, it doesn't get oxidized further. It's fully saturated with oxygen. So, now a powerful reagent use pannalam because you want to oxidize the alcohol. Oxidation of methyl ketones. இதுக்கு ஒரு ஸ்பெஷல் மெத்தட் முன்னாடியே பார்த்துருக்கோம். அந்த இதில் ஆல்டிஹைட் ப்ரிப்பரேஷனில் யூ டேக் அசிட்டோன் ஆர் அசிட்டோஃபெனோன் and react it with sodium hypochlorite. The sodium hypochlorite or sodium hypobromite or sodium hypoiodide, they can all be used, any one of them can be used, and they convert the CH3 group a CCl3 group or CBr3 group or CI3 group அதை கன்வெர்ட் பண்ணும். அந்த கன்வர்ஷன் ஆனப்புறம் அந்த ஹைட்ராக்சைடோட இதுலேயே கொஞ்சம் ஹைட்ராக்சைடு இருக்கும், கொஞ்சம் எக்ஸஸ் ஹைட்ராக்சைடு ஆட் பண்ணி ஹீட் பண்ணாக்க the RCOCl3 group will become RCOOH group. அது the reactions take place like this. The hydroxide oda react பண்ணாக்க get R CO minus CCl3 and then OH. The CCl3 is a very good leaving group because it's 3 chlorine இருக்கு. The 3 chlorine carbon attach பண்ணாக்க it's very highly negative. This will be coming here, it will pull this. The electrons will be pulled easily towards the trichloromethyl group and you get R OH plus CHCl3. This is how this reaction take place. Once the chlorine attach பண்ண அப்புறம் இந்த மாதிரி reaction. இது chlorine இருந்தாக்க CHCl3 வரும், bromine இருந்தாக்க BR3 வரும், iodine இருந்தாக்க CHI3 வரும். The iodine compound is insoluble. CHI3, this is called iodoform, chloroform, bromoform, iodoform. The iodoform yellow precipitate வரும். இது ஒரு important lab test. கீட்டோனா என்னன்னு பார்க்கறதுக்கு இந்த சோடியம் அயோடைட் யூஸ் பண்ணி ஹைட்ராக்சைடில் ரியாக்ட் பண்ணாக்க கார்பாக்சில் ஆசிட் ஃபார்ம் ஆகும். இது சைட் ப்ராடக்ட் CHI3. அது எல்லோ ப்ரெசிபிடேட்டாக வரும். இந்த எல்லோ ப்ரெசிபிடேட்டாக வந்தாக்க original compound is ketone. Next we have seen the oxidation. Now next is reduction. Reduction takes place in 2 different pathways. One is using hydrogen nickel. Hydrogen is the reagent. Nickel, palladium or platinum are the catalysts usually supported in some inert things like silicon dioxide or some other inert polymer. So hydrogen in the presence of these, if you add hydrogen, the nickel, palladium or platinum absorbs lot of hydrogen, and the acetone is also absorbed. Hydrogen is absorbed on the nickel, so all of them together, hydrogen gets transferred to the ketone, you get this alcohol, the secondary alcohol. This is one important way. nickel is the cheaper catalyst, platinum and palladium are more expensive. The product on the pharmaceutical industry ரொம்ப purified வேணும்னாக்க you can go for this. Nickel can be poisonous below above certain levels. So if you use it for chemical use, nickel பரவாயில்ல. But pharmaceutical use you must go to palladium or platinum. They are noble metals. It doesn't react with anything. So இதெல்லாம் contaminate ஆகாது pharmaceutical products. The other reduction method is with lithium aluminum hydride. நான் முன்னாடி ஒரு ஸ்பெஷல் ரிடக்ஷன் சொன்னேன். the aldehyde produce பண்ணுறதுக்கு the acid chloride to the aldehyde in the presence of tri-tertiary butoxy aluminum hydride. அப்போ சொன்ன lithium aluminum hydride is used. It reacts with 3 molecules of tertiary butyl alcohols, and the 3 molecules will displace 1 hydrogen each of the lithium aluminum hydride. இங்கே you don't want very low reactivity. You can use lithium aluminum hydride directly because it cannot get reduced further. முன்னாடி ஆல்கஹால் ப்ரொடியூஸ் பண்ணுறதுக்கு அதை யூஸ் பண்ணோம், பிகாஸ் aldehyde ப்ரொடியூஸ் பண்ணுறதுக்கு யூஸ் பண்ணோம், பிகாஸ் aldehyde can be reduced further. The ketone cannot be reduced beyond secondary alcohol. The lithium aluminum hydride add பண்ணாங்க, the H4 in the lithium aluminum hydride, it will ionize as H minus. Lithium aluminum is the positive charge. That H minus will attack this carbon, which is delta positive. The double bond will come to the oxygen. அப்புறம் வாட்டரோட ட்ரீட் பண்ணும்போது it will become alcohol, it's a secondary alcohol. There is another group of reduction which is both, one of them is based on acid, another is based on hydroxide. இந்த ரியாக்ஷன்லாம் பண்ணுறபோது இந்த மாலிக்யூல் கீட்டோன் ஜஸ்ட் எழுதியிருக்கேன். அந்த கீட்டோனில் மற்ற குரூப்ஸ் எல்லாம் இருக்கும், அமோனியா குரூப், அமினோ குரூப், ஹைட்ராக்சை குரூப், அதெல்லாம் இருக்கும். அந்த குரூப்புக்கு தகுந்த மாதிரி இந்த ரியேஜென்ட்ஸை சூஸ் பண்ணணும். இல்லாட்டாக்க அந்த குரூப் ஹைட்ராக்சை குரூப் இருந்து ஆசிட் இருந்ததுனாக்கா அது டபுள் பாண்ட் ஆகிடும். ஹைட்ராக்சைடு எலிமினேட் ஆகி டபுள் பாண்ட் ஆகிடும். அதனால் ஒன் திங் இஸ், அந்த மாதிரி குரூப் இருந்தால் you have to protect that group by some reagent and then do the reaction. இங்கே this says certain groups which are sensitive to acid should be done in the alkaline medium. Certain group which are sensitive to base, it has to be done in the acid medium. இங்கே ரெண்டு சாய்ஸ் இருக்குது. ஒன்று zinc chloride and concentrated HCl. This is called Clemmensen reduction. It will reduce the double bond by adding 2 hydrogens to get the hydrocarbon. The zinc chloride and concentrated HCl, Clemmensen reduction forms hydrocarbon. The other reagent is hydrazine in the presence of hydroxide. The hydrazine இந்த பின்னாடி பார்க்குறோம். The hydrazine it will react with the ketone to form N double bond C. Here instead of C double bond O, C double bond N, NH2. That's the hydrazine. This is the hydrazine. That compound is called hydrazone. This compound. This is hydrazone. The hydrazone, you react it along with the ketone. This hydrazine is where 2 nitrogens are attached to each other, and hydroxide is also added to the solution. First it will form this hydrazone, then it will undergo rearrangement and get reduced to form the hydrocarbon. The hydrazine you must know that as a side information. It's not part of the syllabus. The hydrazine was used as rocket fuel. Long time back when rockets were discovered, they used hydrazine as the fuel to burn to produce thrust in the rocket. Now we go to other compounds, other reactions where anions add to the ketone. They got a general reaction of nucleophilic addition. These are examples of various nucleophilic additions. The addition of cyanide to give cyanohydrin. HCN on the H plus Cn minus. The Cn minus will add to the carbon here, and this double bond will go to O minus. Then treated with water, it will become OH. This is called a cyanohydrin. The cyanohydrin is a very useful intermediate to produce hydroxy carboxylic acid. The cyanide can be easily hydrolyzed to form COOH group. So these compounds are important, and the hydroxy carboxylic acid produced பண்றதுக்கு the cyanohydrins எல்லாம் intermediate. அப்புறம் இப்போ முன்னாடி அந்த ஹைட்ரசோன் ஃபார்மேஷன் சொன்னேன். அந்த மாதிரி whole lot of compounds can be prepared from ketone by using NH2G, where G is H. When G is H, it is ammonia. When ammonia is used, the resulting compound will have a double bond NH. This compound is called imine. C double bond NH. The two alkyl groups are there, called imine. If you use OH, you get this compound. This is called, if you use NH2, that's NH2, we have seen in the last reaction, that forms hydrazone. If you form C6H5 NH2, that's called phenyl hydrazone. This NH2CONH2, this compound is called semicarbazide, and the formation after the reaction with ketone, the compound is called semicarbazone. These compounds are extremely useful, especially hydrazone, phenyl hydrazone and semicarbazone. அதெல்லாம் வந்து சாலிடாக ப்ரொடியூஸ் பண்ணி கிறிஸ்டலைஸ் பண்ணி மெல்ட்டிங் பாயிண்ட் எடுத்தாக்க அந்த மெல்ட்டிங் பாயிண்ட்லேருந்து என்ன கீட்டோன் ரியாக்ட் பண்ணியிருக்குன்னு தெரியும். பிஃபோர் ஸ்பெக்ட்ராஸ்கோபி, ஐஆர், என்எம்ஆர், மாஸ் ஸ்பெக் இதெல்லாம் வரதுக்கு முன்னாடி இந்த மாதிரி இந்த மெல்ட்டிங் பாயிண்ட் வச்சு தான் ஸ்ட்ரக்சர் டிட்டர்மின் பண்ணாங்க. அப்போ வந்து இந்த NH2 which is hydrazine, NHC6H5, phenyl hydrazine and semicarbazide, these the resulting hydrazone, phenyl hydrazone and semicarbazone அதை கிறிஸ்டலைஸ் பண்ணி மெல்ட்டிங் பாயிண்ட் கண்டுபிடிச்சி அந்த மெல்ட்டிங் பாயிண்ட்லேருந்து என்ன கீட்டோன் வருதுன்னு தெரியும், என்ன கீட்டோன் ஸ்ட்ரக்சர்னு தெரியும். Now this is a reaction where ketone is reacted with alcohol, and you get இங்கே வந்து புரோட்டனேட் ஆகி ஒரு ஆல்கஹால் group will come, and மறுபடியும் புரோட்டனேட் ஆகி இன்னொரு ஆல்கஹால் group come. This is this particular compound where two OR groups are attached in the carbon. This is called ketal. இந்த குரூப் OR group ரெண்டு குரூப் அட்டாச் பண்ணாக்க aldehyde and ketone forming ketal and acetal respectively, the compound கொஞ்சம் more stable ஆகிடும். இந்த R குரூப்பில் ஏதான ரியாக்ஷன் பண்ணணுன்னாக்க this can be called protective group. அந்த மற்ற குரூப்போட ரியாக்ஷன் பண்ணுற போது இந்த OR குரூப் வந்து அந்த ரியாக்ஷனில் you will not make it very difficult. It will make it easier. Therefore this is sometimes used as protecting group. Next is Cannizzaro reaction. This is a typical reaction. First with aldehyde. The two formaldehyde molecule react pannaka. One formaldehyde group gets oxidized, another formaldehyde group gets reduced. It's called a disproportionation reaction. One on the oxidize aayi, innone reduce aagudhu. This Cannizzaro reaction, if you do it with aromatic aldehyde, the same type of thing happens. Usually this is done in alkaline medium, and two molecules of metachlorobenzaldehyde. Inge chlorine irukano. One on the metachlorobenzoic acid iodine, இன்னொன்று metachlorobenzyl alcohol. Same kind of disproportionation. ஒரு aldehyde group acid group ஆயிடும், இன்னொரு aldehyde group CH2OH ஆயிடும். So this is a method for synthesizing some carboxylic acid or primary alcohol. மற்ற மெத்தடில் முடியலனாக்க இந்த Cannizzaro reaction யூஸ் பண்ணிக்கலாம். இது வந்து crossed Cannizzaro reaction. ஒரு aldehyde aromatic aldehyde, இன்னொன்று formaldehyde. இதை react பண்ணாக்க the formaldehyde gets oxidized. It's a good reducing agent. It gets oxidized to and that hydrogen is transferred to this aldehyde to form CH2OH. Again, very useful for preparing primary alcohols when other methods are not useful. Now, I mentioned earlier the preparation of alcohols by using addition of Grignard reagents, reaction of Grignard reagents from ketones and Grignard reagents. If you have a ketone RCO R prime and reacted with R double prime MgX, we saw lithium aluminum lithium dialkyl copper. Similarly, you have magnesium reagent. Magnesium is partially positive, the R group is partially negative. இது நெகட்டிவாக இருக்கிறதுனால இது வந்து இந்த கார்பன் அட்டாக் பண்ணும். இந்த கார்பன் அட்டாக் பண்ணி you get this tetrahedral compound R prime R double prime OMgX. When it attacks R prime R double prime attacks, you will have this bond formed and it will become CO minus. இந்த O minusல OMgX attach ஆகிடும். இதை வந்து water or with little bit of acid, if you break it, you will get the OH group. This will proton will attach to the magnesium and also hydrogen or oxygen and form alcohol. This is a tertiary alcohol. Usually this compound works well to produce tertiary alcohol. If the RR prime is formaldehyde, you will get primary alcohol because 2 H's and you add only 1 R and OH, you get a primary alcohol. If it is instead of 2 hydrogens you have aldehyde, then you get a secondary alcohol. If you have R and R double prime, you get tertiary alcohol. When R is equal to R prime is equal to H, final product is primary alcohol. Whereas when R is equal to R and R prime is H, then you have product will be secondary alcohol. In this case, you get tertiary alcohol. Alpha halogenation. When you have carbonyl group, because of the electron withdrawing effect, the neighboring proton on the neighboring carbon becomes very easy to remove a proton, become acidic. So, when you react with X2, you get a negative charge here, it reacts with X2, take a halogen and remove another halogen as X minus. This is called alpha halogenation. When the produces it proceeds further, you get the dihalo and trihalo compounds we have seen in chloroform, bromoform and iodoform formation. This is the first step in the formation of those compounds. Here again the same reaction is depicted here. Iodine potassium hydroxide, we get CHI3 and hydroxide. We will remove this as CHI3 and you get a carboxylic acid.